aviation is built on trust, and that trust is earned through maintenance. Long before advanced aircraft filled the skies, aviation pioneers understood that mechanical reliability was the difference between success and disaster. The earliest examples of organized maintenance appeared in the 1920s and 1930s, when air forces and early airlines created small workshops to repair wood and fabric aircraft. As aviation grew, these scattered workshops evolved into structured maintenance organizations. By the 1950s, with the arrival of metal airframes and the first commercial jetliners, the concept of a certified MRO was formed. The industry needed professional facilities that followed documented procedures, technical approvals, and strict airworthiness rules. This is how the modern MRO sector began. Today, MRO stands for maintenance, repair, and overhaul. It is the full ecosystem of technical services that ensures every aircraft remains airworthy. An aircraft cannot legally fly unless it is maintained by an organization approved under international regulations. In Europe, this is EASA Part 145. In the United States, this is FAA Part 43 and Part 145. In the Middle East, it is GCAA CAR 145. These regulations define what qualifications engineers must have, how documentation must be managed, and what standards maintenance must follow. They also link closely with Part M for continuing airworthiness, Part 66 for engineer licensing, and Part 21 for design approvals. To understand how MRO works in practice, it helps to look at the types of MRO shops that exist. The first category is line maintenance. This is the maintenance that takes place at the airport where the aircraft operates. Line stations handle daily inspections, turnaround checks, minor repairs, fluid servicing, tire replacement, and troubleshooting. These stations keep the aircraft ready for flight with minimal downtime. The second category is base maintenance. This happens inside large hangars designed for deeper inspections. Base maintenance includes A, B, C, and D checks. A checks are light and performed frequently. B checks are less common in modern programs, but still exist in some fleets. C checks require opening major panels, inspecting structures, cleaning systems, and performing functional tests. A D check is the most extensive inspection in the life of an aircraft. The aircraft is almost completely disassembled for structural examination, corrosion control, and full system checks. MRO organizations that handle base maintenance follow stricter approvals and require specialized equipment, tooling, and heavy engineering teams. In addition to line and base maintenance, the industry includes highly specialized MRO shops that focus on individual systems. Landing gear MRO shops are a key example. A landing gear system is removed from the aircraft at scheduled intervals defined by the manufacturer. The entire gear is disassembled, cleaned, inspected, measured, repaired, shot peened, repainted, and reassembled. Shock struts, actuators, brakes, cylinders, and bushings are restored to approved tolerances. The final product undergoes functional testing that simulates real aircraft loads. Landing gear overhauls follow detailed OEM manuals and regulatory requirements because they directly affect takeoff, landing, and emergency behavior. Engine MRO is another large sector. Engine maintenance covers bore scope inspections, hot section work, fan restoration, turbine blade replacement, compressor work, and complete engine overhauls. Engine shops include test cells that replicate full power conditions to ensure correct thrust and performance. Engine MRO is governed by Part 145 approvals, combined with the engine manufacturer's own repair standards and service bulletins. Component maintenance organizations focus on thousands of individual aircraft parts. These are known as component shops or back shops. They handle mechanical parts, pneumatics, hydraulics, avionics, electrical systems, batteries, oxygen bottles, wheels, brakes, and galley equipment. Every component repair follows the CMM, which is the Component Maintenance Manual. Component shops must maintain calibrated test benches, proper storage conditions, traceability for all parts, and quality systems aligned with 145 regulations. These shops return components to service with EASA Form 1 or FAA 8130 certificates. Structures MRO shops specialize in repairing fuselage skins, frames, stringers, doors, wing panels, and composite parts. These facilities use advanced techniques including bonded repairs, heat blankets, autoclaves, and non-destructive testing. As more aircraft move toward composite construction, structural MRO continues to grow in complexity. Avionics MRO shops deal with modern digital systems such as flight computers, communication radios, navigation units, displays, and sensors. These shops require clean benches, advanced testing systems, and highly trained technicians because avionics directly influence aircraft automation, navigation accuracy, and flight safety. Another essential part of the MRO environment is the workshop network inside large MRO facilities. These include hydraulic back shops, electrical shops, NDT departments, machine shops, composite repair rooms, wheel and brake shops, and calibration labs. Each workshop follows strict procedures for control of tools, equipment maintenance, and quality inspection. The connection between MRO and the A, B, C, and D check system is fundamental. These checks determine when the aircraft enters deep maintenance and which components are removed for overhaul. For example, during a C check, many components are removed and sent to specialized MRO shops. An aircraft in a D check undergoes structural inspection that only a heavy maintenance facility can perform. The timing of these checks is determined by the aircraft maintenance program, which itself is based on the manufacturer's recommendations and regulatory approval. An MRO organization cannot operate independently from regulation. EASA Part 145 defines the responsibilities of the accountable manager, the quality manager, certifying engineers, and base maintenance engineers. It requires proper tooling, calibrated equipment, environmental controls, technical data availability, and detailed training programs. FAA and GCAA mirror the same principles. These regulations ensure that maintenance quality is consistent worldwide. In modern aviation, MRO is a combination of engineering discipline, regulatory compliance, and specialized technical skill. Whether it is a landing gear overhaul, an engine restoration, a flight control repair, or a simple line check before boarding, each action ensures the continuing airworthiness of the aircraft. Without these shops and the rules that guide them, aviation would not be able to operate safely or efficiently,